Okay, so I just wanted to very quickly go over some basic Solana concepts. I think a lot of the tutorials out there skip over what's going on under the hood, and I always like to play with very fundamental building blocks of a blockchain first, so that I understand if something goes wrong, and I can debug easily, and I have a wider range of tools at my disposal for debugging or I guess it's just fun. It's more fun to code that way. Anyway, so I've created some projects before, but I'll ignore them first. I'm going to assume that you already know the command line a little, at least. It's very basic. If you don't have it set up, then go to Solana, docs.solana.com and click command line guide. I have 1.7.11. I don't know if that's the latest or whatever, but because I had to compile this myself to run on an M1, it's not, which also is not that surprisingly pretty easy. Anyway, set it up, understand it. There's not too much to it. You don't actually have to use this CLI tool to be productive on Solana. You can completely bypass it if you need to. I just think it's faster for some things. One thing is creating keygens, which is essentially just a wallet. A wallet consists of a public key and a private key. Those are kind of mashed together in a ED something something. I can't remember the name of it. It's a elliptical curve encryption mechanism. Anyway, so you can sort of like use the CLI tool to create wallets or create key pairs and then pull them back out. The reason that you would want to do this, or pull them back out in your code, the reason that you would want to do this is because unlike Ethereum, just to run a blockchain query that queries a program or a smart contract costs some Solana. And it's only a minute amount, but it does cost. You need to have a funded wallet. If you don't, it won't work. You can query basic information in a read-only fashion, just like Ethereum, but not if it's in any way dynamic. And that differs from Ethereum. Ethereum does allow you to sort of have some processing on the node end, and you can sort of call read-only methods called view methods, and they are free. The reason is because obviously if something mutates data on the Ethereum blockchain, it needs to go through the consensus mechanism, which means that all the nodes need to agree, which again it takes more processing power, is more expensive, and will cost money. Just reading though is free on those chains, so it's important to understand that Solana is built differently. It consists of accounts, and accounts can contain programs, and also data. And accessing that data, that big chunk of data, is free, but modifying it or calling a program costs. The data itself is just this big binary blob. How you deal with it is completely up to you. And I find that interesting and off-putting and cool all at the same time. The crux of it is you're going to have to decide how you want to serialize and deserialize. And that means like putting the data into this binary chunk and getting it back out on the other end. But everyone's sort of using a library called Borscht to do that. We won't be using that today. I'm going to show you how to do it yourself, just because there's some interesting stuff that you would skip over if you just followed the other tutorials that just sort of show you how to use Anchor or show you how to just basically serialize and deserialize using Borscht. So I've created a key pair already, and I'm going to show you my private key. Oops. I'm going to show you that I have like a, what do you call it? Solana key pair. Yeah, so it stores like your private key as an array, which is kind of weird. You may think at first like, why would it have a serialized array? And it's just simplicity of reading it back into a buffer. So a lot of things in Solana use the node buffer to transport data around, and this is no different. So each of these obviously represents uint8, and once it is collected into I think it's a base 64 encoded string, I'm not really sure, but when it converts it into a string, it then uses that as both your public key and private key, so it creates an account from that. Not a big deal, it's just that we will need it, in the future, so I'm just explaining it now. Okay, so the first thing we might want to do is create a new project. So let's go into, this is Solana, choose whatever you want. I'll go cargo new. So I want to create a new cargo project, which is obviously Rust's package manager. I'll call it Toki. Okay. Oh, I think we have to do, how do you do lib? I think is that right? Yeah. So the reason I want to do lib is because I'm not creating a binary here. I'm creating a library, and that's because the output that we want cargo to produce is a bytecode for the for the virtual machine that sits on Solana, which is called Berkeley Packet Filter, or in this case, it's eBPF. Other blockchains use different kinds of bytecode. There's EVM for Ethereum, or a lot of the other cool kid blockchains are using WebAssembly. This uses a archaic, weird system that is usually used on routers, and the reason is because I guess the developer felt that low-level access to the network layer was important, and maybe more important than relational data or various other niceties that are given for free in other chains. Personally, I find it's annoying, but we'll see. So yeah, I've got a cargo and cargo.toml and a source directory. So I think we want our lib to be a. Okay, I'm going to reference my other project a little here. I don't know everything off the top of my head, and I don't know any developer who does. Highly recommend that you get like IntelliSense or use IDEA and install every kind of help that you can. And I never used to be like this. I used to use like Vim, and it never used to hook up to anything. I'd use it as a text editor, and before that, TextMate. That was a mistake. The good thing about compiler is that it can help you if you let it. It can also annoy you if you let it. The way that you can let it help you is through your editor. So you hook up tools like Rust Analyzer or TypeScript's TSC or whatever it is to your IDE or your editor, and then it'll push you in the right direction. And I'll show you that a bit more of that later, of how I might do that. But there's no point memorizing everything. It's a waste of time. Your editor can help you. Your compiler can help you. And this is why types are so amazing. They will save your life. Anyway, so we're creating a C dynamic library. It's just, we're not actually creating a dylib, to be honest with you. It's just the format that we handed over to the real compiler. Cargo kind of creates a bytecode that sends it to a compiler. In our case, our compiler will eventually compile to eBPF bytecode. So let's look at our library. It's junk. First things first, there is actually some interesting stuff. I did first look at this article, polx.dev. I think it's the only article in his site. It's a escrow, which is really interesting. But we're not going to create anything that sophisticated. We're actually going to be way more ghetto. I'm going to start by. Oh yeah, he's got this program. He's got this. He points to this. This isn't his actually. He points to this as an example for where to set up. And this is also really, really basic. I don't think we need this. I think we can start from scratch. But you can sort of look at his cargo.toml. He's got like Solana program. Okay, so what I usually do is I'll get the latest version, of course, first. Okay, so his is on 1.7.11, 1.4. Okay, we need to cargo build just to make sure that everything's working. This is blocked because of my stupid editor running cargo check in the background, which I just said was a good thing, but I'm not so sure. Hurry up. Okay, while we're waiting, I'm just going to check out. Yeah, so if we go into his, or this template's source in lib, Okay, so you can see this is just test. Most of this is just test. So this is the only bit of program that they give you. Let's just chuck that in. So this is quite small. Yeah, this is like nothing. And actually, some of this is optional too, because it's just printing out a message, which is like a console.log, and it's printing out what you give it. So essentially, it's just one macro. Like that's the core of all this, is telling the compiler where to mark the entry point, the main, I guess, and it's saying, hey, this function is going to be our main. Macros is a system of pre-compilation, so it's going to do stuff under the hood that marks it as an entry point. Any entry point is given the same data all the time, so you're always going to get this: a program ID, an array of accounts, and possibly data. And on the client side, you have to remember this because that's exactly how it's called. Let's go back to our lib. What are you doing? Oh, it worked. Okay. Now, another thing that you need, which would have been described in the Solana docs if you followed it, is installing the build tool, build BPF, and instead of cargo build, using cargo build BPF. If you have WASM or whatever, they have their own build tools as well. I believe that this first compilation was actually a system compilation for x86 so that the IDE can work. It just runs cargo check. You could compile all these Solana programs just for regular x86 and run them like CLI tools if you wanted to, but why? Anyway, so once this is done, okay, so this is successful. If you get this far, you're good to go. Everything's working. So you can see here that the Solana CLI tool has a deploy mechanism. If I deploy this, this is actually pushing it to the devnet. And it's using my wallet. As I said before, you need some Sol in your account. If you don't have that, I'll show you how to do it. I'll create another tab. Okay, so if we go Solana balance, okay, you can see here, we've got 3.6 blah, blah, blah. If you want more, Solana airdrop. You can't do that on mainnet, just devnet and testnet and local net. Yeah, and that'll just, oh yeah, you need an amount, so 1. Requesting airdrop of 1 Sol. Oh, it failed. This, yeah, rate limit. Okay, this is another thing. Solana is stingy as anything. They will rate limit you for anything, for requests, for anything. The devnet can go down at any time. They really need to fix that. It makes development a painful experience. Anyway, you know how to do it, and that will append that airdrop into the wallet that is in the key pair that the wallet that is pointed to here, and I'll show you how to use that in code later. So, okay, thanks. Anyway, you can see here that the program has deployed to this ID. Program ID is just like public key, just like your regular Solana addresses. Works the same way, has a private key, but you're not privy to it. Anyway, if we go to the Explorer, hopefully you know what a block explorer is. We just jump on. Okay. Whoops, devnet. Okay. You can see here, it's a program, so it's marked as executable. It transfers some Sol to the account. This is for rent basically. If programs have a certain, or if accounts have a certain amount of Sol in them, they are rent exempt. Otherwise, it's just going to chew up any Sol that's in that account. That's for temporary accounts, I guess. Anyway, it's sort of a staking type mechanism, I suppose. Anyway, upgradable, yes. Okay, so this is very important. This means that this program is actually mutable at the moment. I can override it, and every time that I deploy, I will override it. What's interesting is, I'll show you how to do that. So if I use the Solana logs tool, and followed by an address, so the address of my, where is it? Address of my deployed program. There. This is just going to create a WebSocket. Now, it doesn't last very long. It lasts a couple of minutes, this WebSocket, which is kind of annoying. But it is listening for any transactions that take place, mention that address. So I'm just deploying again, and it should overwrite the previous deployment. So 279 transactions. That's great. Okay, finalizing. Okay, upgraded program. So you can actually mark it as non-upgradable. That's another topic. So yeah, I guess anytime that you look at other code, they generally tend to follow a bunch of best practices, I guess you could say. Programs usually have a key at the start. So it's 8 bits of data, right? And it's like a number. The reason that this is good is because you can just pull off the first byte, sorry, of the data buffer, and then you switch it based on what event type it is. It's usually called key, but it can be called anything. So if I was to split off the first here, like key, oh wait, I guess you const key equals instruction data dot get first, I think. Is that right? Key should be a U8. Instruction data, attempt to use a no constant value. We'll come back to that. Oh yeah, what am I doing? That's right. No method named get first. Okay, I think it's like option. Now, never use unwraps in your actual code. Okay, cool. All right. Yeah, so in your production code, you don't want to use unwraps. This is same with all Rust. You only use it in messy code that you're just trying to like work out what's going on. Never push production code, or never push code that other people are going to use with unwraps. It's very impolite. Anyway, so if I match on this key, say we have a 0, 1, and a default. Okay, so you can see here that this is using this message. I'm going to reuse this macro. I'll go 0 and 1 and 2. Oh no. Error. Okay, cool. Now, I don't think we need that anymore, so I'm just going to remove that. All right, now we've got a little switcheroo thing with our basic program. But what's the use of all this if we can't call it? So I guess I'm just going to create a little client. So make dir CLI, I guess. CD CLI. Okay, let's node yarn init. Okay, what are we going to call it? CLI. Yep. All good. Yep. Okay, list. Yarn. Oh wait. Yarn add. Dev. TypeScript. Node types. What else do we need? What does it say here? Okay, let's make our main file a TypeScript file. Touch index of TypeScript. Oh, that's dumb of me. Types node. Maybe I'm dyslexic. Does dyslexia apply to words? I don't know. Okay, CLI. Okay. Now, NPX. Oh, of course, this is really important. I like to create these like little CLI tools because if you start creating like actual integration code, actual production code, whatever, if you start creating that in your React app to start with, not only is that going to end up not portable, it's also not very testable. I mean, you could argue with that, but I like to create like an isolated area where I can quickly test things and work out what's going on. Not for every project, but particularly for this example, CLI tool is just really useful. And I found a lot of Solana projects agree with that. They create their own like little CLI tools. Okay, so if you want to do that with TypeScript, it's a little bit more complicated. So what we need is a thing called TS Node. What that's doing is that's going to run the TypeScript compiler as if it was in a Node environment. So how you'd run that, now that I've installed that package, is tsx, which means like use the package dependencies, I guess. TS node index.ts. Now, I don't think there's anything. Yeah, okay, so console log hello. Oh, hello. Okay. That's right. Oh, npx. What am I doing? TSX. npx. Okay. Yep. Cool. Hello. Done. All right. That's our CLI tool done. No, just kidding. Okay. So we've got we've got to add a bunch of stuff, I guess. I'll just copy the I usually like create examples with in a certain way. So I like to create it like this. I actually borrowed this from Hardhat. They have this bootstrapping code, and it's really good because it makes sure that all of your code is run asynchronously, and it catches all your code in one spot. So calls main, then if everything's okay, it does a proper node exit. Otherwise, it catches the error, prints the error. And the cool thing about that, and it returns a correct error level. So it'll integrate with other scripts and stuff if you really like that. Yeah, the other thing is like it's one simple place to put a breakpoint if you're using a debugger. Anyway, so we've got that. Let's run it again just to make sure. Yep. Okay. And okay, cool. So one of the tools that if you're familiar with Ethereum, there are two major client tools or providers for Ethereum, Web3 and Ethers. So if you're familiar with Ethers, it splits the types of requests, I touched on this before, into providers and signers. And a signer is a transaction that has a signature to it, and it usually is used for mutating data on chain. If you are a signer, you have the permission, or your permissions are elevated to the point that you can then create a mutable request or a signed request. Solana doesn't have this. Everything's a signer. So the web3.js library is going to assist you to create signers. Now there is some what do you call it? Like read-only immutable data that you can get. You can read any program, any account's data, or you can read any account and get the balance from it or whatever. But you can't run or execute any program methods. So the library that we want to use is Solana Web3. So let's add that, and that will allow us to create a connection. And the connection is analogous to a provider in Ethers. And then you can get your signer from various different ways. You can get it from an injected wallet like Phantom or MetaMask, or you can get it from a ledger, or you can get it from a key pair. And in our case, of course, we want to use a key pair, particularly that one that we created before. So I was scratching my head on how to do this for a while, but it's pretty basic. Whoops. Another thing, when I import libraries, I don't do the other ESM syntax where it's like imports all these little bits and pieces. It's just messy, and you end up with all these orphaned like imports and stuff. And a lot of people check in code with orphaned dependencies and stuff like that. It's easier to tell where something's coming from if you declare it as in a module namespace. And you can also like just do web3 dot. As I said, like I use the editor to try and help me all the time, and this is like a great way to help with that. It just is very obvious where everything comes from, and there's no overlap. Like especially in Web3, you get like key pair being defined somewhere else or different names being defined somewhere else. And you're like, where did this one come from? So it can be tricky. So misdirection. Anyway. So the first thing that I need to do is create a connection. So I can do this outside the file. I know it's not that great, but connection equals web3.connection and web3.cluster get cluster API URL. Now all this is doing is returning a string for DevNet, but it's kind of a best practice way to do it, to grab the string using this function. You don't have to. You can just use the node URL directly. Anyway, well, we don't actually need that. Okay. Cool. So, if we wanted to just query the blockchain now, we can, but only a certain amount of data. We can. So all of the read-only transactions that I was talking about, this provides like a layer that just under the hood, it just uses like some internal like RPC request, RPC whatever, that makes a request to the node, given some method, predefined methods. You won't be doing that actually. Unlike Ethereum, where methods are pretty explicit, in this you're not really calling methods, you're calling a program and stuffing some data into it, and on the other end it's kind of like deciphering that and going like, well, what do I do with this? And then that's all up to you. So let's have fun there. Yeah, so as I was saying before, like this is my secret key. So you can see here 61. Oh wait, no, that's different. Okay, if I want to create a secret key from the wallet, from the Solana CLI wallet, I can just grab this. Again, like this is just testnet data. Like if you really want to use this as a, if you want to steal my DevNet sol, you can. Okay. Okay. So here's our key. Web3 dot. Oh, now we're creating a signer, which is again that key pair. We can create a type for it if we want to. Key pair equals web3.keyPair dot from secret key. Okay, and there we go. We've got the signer, and that is the same signer that is used on this one. If you want to verify that, we can use the connection dot get balance, and then we'll use signers public key. And then on return balance, and then we'll return it console.log sol and balance times divided by web3 ports per sol. Again, like the reason for this is ports per sol is about 1 billion, I think. Yeah. So a port is like a Satoshi or like a Gwei. It's a fragment of the base currency. And the reason that we have to do all this dividing and addition, that most contract languages don't support floats, is because of rounding errors and crazy stuff that it's trying to avoid during conversion from a floating point into an integer. It's just cutting down the amount of times that it's being carried as a float, because yeah, it's notorious for producing errors basically. Anyway. Yeah, contract languages shouldn't have floating points. There are arguments against that, but you know. So let's try it. Actually, yeah, npx ts node index.ts. That did not work. We've got to do a wait. There we go, 3.6. Now, if I go Solana balance. Yep. All right. You could also do the same with address to verify it, but whatever. Anyway, so let's nuke that. Okay, so I guess we want to call our program. So how we do that is we collect together a bunch of instructions into a transaction. So let's build a transaction. Transaction web3.transaction equals web3 new web3. You don't actually need to put that type if it's directly followed, I guess. Yeah, whatever. It's nice. It helps you, I guess, in some points. But if you are chaining a whole bunch of functions, you definitely want to make sure that you're restraining by type. If you're not, then your editor can't help you. It just doesn't understand. And I don't blame it. How could you? Anyway, so new transaction.add. Okay. So we're just adding one transaction, so may as well. You can just keep chaining these adds if you want. New web3.transaction instruction. Okay. So transaction consists of instructions. Again, like this is a case of like using your editor to find out what the hell's going on. Like it says here the ops is not provided, so let me provide some options. Oh, what are the options? It says here keys program ID. Keys. Let's make it an array. Program ID. Let's make it undefined. No, let's just yeah. Okay, so this looks familiar, right? Keys, program ID. Remember keys, program ID, data, or yeah, program ID, accounts being keys, data. Okay, so in the Rust side, this is where it's receiving it. On the client side, this is where it's sending it. As I said, like keys are all of the signatories for signing this transaction. Yeah, the reason for signing is, of course, security. And the program ID is the program that we launched previously. So I was monitoring it here, and this was the address of it. So I can just put this as a constant. So program ID is new web3.public key. Yeah, so program ID, as I said, is public key. So we just provide that to our transaction. We don't need any keys at the moment because we're not really modifying data. Yeah. So how do we send this transaction? Okay, so await connection. Most transactions are created with either down the line somewhere they're using this Web3.js, or you can either use connection or Web3 directly. So there's like get transaction. That's the most basic form of a transaction. But most people tend to use Web3 send and confirm transaction. Yeah. Connection, transaction, which we created before, and signers, which I explained before. And there is also an options, but we don't need that right now. I might actually just put then, and then just so this is a signature that it ends up with. Send and confirm transaction. As you can see, it returns a string, and this is the TXID, or the signature. In most other blockchains, it's called the TXID, it's transaction ID. But in Solana, for some reason, they call it signature. Everything's called something different in Solana. It's really annoying. Okay, so this is a pretty bare bones transaction. Okay, it's not sending any data. It's just kind of like pinging the program for no real reason. Let's see if we can get it to listen. So if I execute this program, okay, no signers. We do need a signer, so let's pop it in the signer array. And oh, you can see here. Okay, that's our log. So these three around here, around our transaction, are created by the program's parent. I'm not sure if that in this case is the system program or if it's the BPL loader or BPF loader or whatever. But it's one of them. And you can see here that it does consume Solana, which is kind of crazy because we didn't do anything, and it's charging us. I feel ripped off, but whatever. So this is our log. This is what our program spat out, what we paid for. So let's look at the Rust again. And you can see here it's purely printing out. It's printing out process instruction. Because we didn't employ, we didn't deploy the latest version. Okay, let's deploy the latest version. Cargo build BPF. Oh, Carbo. Sounds cool. I'm just gonna make sure that the log is working. Okay. Yeah, take your time. Come on, Turkey. You can do it. Okay, done. Now deploy. This should overwrite, should upgrade. I need that upgrade. Oh, yeah. Okay, we're upgraded. Alright, now let's see if we can actually, let's just create a script for this because I'm annoyed. Scripts. Okay, go. npx ts node index.ts. Go. Nope, it's not going. Unexpected. Oh, I always do that. I'm such a bad coder. Yarn go. Okay, so what do we got? Simulation failed. Okay, this is because we are expecting data on this end. We're expecting data. This unwrap is throwing an error. So if I was just to print out a regular message, it'd be fine. But yeah, we're expecting data. So let's go back here. Let's give it data. Const data equals. Oh wait, it has to be a buffer. So yeah, buffer equals buffer from blah. Okay, now let's try. Oops. Let's erase. Error. Dumb. I feel stupid. My code's insulting me. Okay. Why is that? Okay. Error dumb. Let's make it print out the instruction data when we get an error. Oh, debug. Okay. Let's not be so dumb this time. It's still gonna call us dumb. Just be prepared for that. Oh. It's hurtful. Oh, we need to deploy it again. Okay. Cargo build BPF, and I can't. I don't know what it is. I can't remember. Okay. Solana program deploy. Not really compile that. Okay, whatever. Yeah, we'll get there. Now don't cut out. Upgraded. Okay. Now go. Yay. Okay, you can see this is the data that was sent to us. If we look at the data from the client side, blah. This is blah as a UN8 array. Cool. Okay, we're getting it. So the first byte here will be 98, and what we want is to match it up with our match. What whatever, to be 0 or 1. Anything else is considered an error, and this is known as a key. So let's stick that in there somehow. So what we do is go a uint a array dot from, I think, 0. Okay, is that right? Okay, hang on. Yeah, buffer from of, not from. Yeah, so of 0. Okay, it's about to get a little technical, but not too bad. So at least we can just do this. Oh. All right, there we go. 0. Yay. It worked. And if we wanted to go with 1, just check it for fun. Should say 1. Come on. 1. Okay. All right, so our switch is working. This is how the serializer works. Sorry, not the serializer. Yeah, it's how the deserializer works. But instead of doing it into numbers, pulls it off and compares it to an enum. Anyway, now we might want to deserialize some data. I'm not going to use Serde or Borscht or whatever. Just going to kind of wing it. So let's say if we get 0, then I'm going to create a block here. What happened? Message, where'd you go? Okay, okay, so we want value. This will be we'll pull an additional value. It's just a U64 off the stack, or whatever you want to call it. Now, this means it's going to need padding. You're going to need 64 bits. So for 8 bits, so it's going to look like an array of whatever, 4 things. Anyway, so if we start by declaring our data type, this is what we want, and we're not going to compromise. So let's get instruction data. Oh, wait. First, yeah, okay. I think there's actually a better way to do this. So if we go with split first, yeah, split first. Okay, split first, then that's going to give us 2 values. So the key and then the remaining. Okay. Just going to remove that for a second. Okay, so these are pointers to U8s. I could type them, but I'm super lazy. Should I? No. Okay, you get it. Okay, so key still matching. Instruction, but we've got, this is rem. So rem dot splits at. Oh wait, no. It's get. So get will split splice from an array. So 0 to it's actually 1 to 9, which is, wait, is that right? 0 to 9, I think so. If it's not, I'll work it out. Okay. Now, this is what I was saying before about letting your type system work for you. So it's giving you hints about type hints. So it's still in its buffer form, even though it's like a slice. It's still an array of unsigned 8-bit integers. So we need to somehow coerce that. And in Rust, that's done with traits. So we use standard. See, this is again beautiful autocomplete stuff because I've installed all my garbage. I think it's like into or something. I can't remember. Convert, yeah, it's going to convert, and then try into. Yeah. Okay, so that's sort of applying like a trait to all, to various kinds of. You can go into here. You can go into the source and read it. I highly recommend that you always read the source because the Rust source is really cool and it'll give you great practices on how to deal with things and what everything's doing under the hood. So we need to, okay, so once we get, you can see here that it's returning an option. So if we want to map that option or whatever, we want to transform that option. We have the option of map, or we can use and then. There are various different like functions we can use to sort of pull in. This is the basics of Rust programming, is dealing with all these monads, like result types and stuff like that. And then, and map and all those things are things that you end up getting really, really used to, because you end up knowing what the type is of each thing is as you're getting it back. Some people even comment like here what the type is, but I think that's overkill. So right now we're at and then, and so we've got a splice out of that, splice, and then we want to splice dot try into, I think, and then we want a U64, I guess, and then that's going to be a result. So I should say that somewhere. Trying to, but that's going to be a result. So we actually need it to be a option. So I guess that's like okay. Now what do we have? Expect a U64 and it's got an option. So I guess we could just unwrap it. Like, again, don't do this in regular code. But yeah, so try into, this takes no generic argument. Okay. Oh yeah, so it's just going to coerce it based on what it finds. Trait bound from is not satisfied for U64. Okay. So try. What do I do here? Trying to, yeah, should be fine. Get, oh, it's not 8. Not 8. That's not right. Oh yeah, because it's a remainder. Yeah. Yeah, actually, you don't even need to slice this, to be honest. Like, it should be the whole rest of the data, but of course you could get under or over and then it wouldn't throw an error. Okay, so we have trying to slice, splice, slice, like try into get, and then yeah, that should be fine. And to U64. Ah, okay, yeah, right. I'm going to convert the bytes. So essentially, like what we did on the client side. Where are we? Here. Okay. Yeah, we need to transform the data into little endian bytes. So anything that we pass through, the BPF program deals in little endian bytes. So it's not too much to worry about. Just to make sure that yeah, Borscht will take care of it for you. But it's really valid to sort of understand that conversion process is going on anyway under the hood. And you can see like there's so many like spaces here for errors. So error handling is really important. Again, not something that we need to really get into. So this should convert the second part of the data into an extra variable. So 0 and then value, and I'll put that here. So if we do it now, it should throw an error, I think, because we're not providing any additional data. So that unwrap will cause us to fail. Oh, okay, 1. Oh yeah, because yep, right. Okay, so 1 is fine because it's not actually going to slice that. It's if we hit this 0 block. So if I hit 0, it should give us an error. Where are we? 0. Okay, I guess it just decoded it as nothing. Oh, we didn't deploy. So cargo build BPF. Come on, Toki. Okay. And we deploy. You could actually create a task for this really easy, but I'm super lazy. There we go, and should get an error. Yeah. Okay, so unwrap on a none value. So it's a typical Rust error when you're trying to call unwrap on invalid data. So it's actually an error. Yeah, or in this case, it's a none value. The monad is set to none. So yeah, it was an option. Tried to unwrap it, and it was a none. You can use unwrap or else or whatever. That would be the best way to sort of deal with this. So go unwrap or else 0. Oh, unwrap or 0. Yeah, that would mean that anything that you pass there, if it was invalid, it just gives you a 0, like a default. But it doesn't complain. So it's really not adequate for proper error checking or error handling. Okay, so our next step is to actually pass it some data. That's the last thing. So data's here. This is actually an array or a bunch of values that it compresses into a uint array. So if we create a new thing, anything that we put in here, it will add to our uint array. So we want a big number. You can put anything actually, but I guess we could put a number. 4. Does that work? Yeah. Okay, we can do that. But I want to put a big number in a second because I want to encode it. But let's just check if that works. Actually, I don't think it will because it's trying to pull 8 bytes. So it'll just be 0. Okay, yeah, unwrap on a null value again. So that's because we didn't deploy our recent change with the unwrap handling. So there's not enough bytes there. So basically, like it needs to be encoded into little endian, and it needs to be padded to 8 bytes. So how we might do that? Well, we can use BN, which is handy because it's got like it's basically a wrapped buffer, so it's a lot easier to use. So if we use BN, new BN, and I think like you can import BN from bn.js or equals require bn.js. I think that's right. Oop. And then yep. Okay, so new bn, and we want like say 44 because that's cool. And then we want to create an array out of it. Okay, so I'm just checking my last code. Yeah, because my brain is dying. Okay, so yeah, we convert it to an array. That's right. So again, we want to convert it to a little endian array. So this is like a function. This is why I was using bn instead of just a number by itself. It's got this handy helper function here. Yeah, so much easier. Also, like most of Solana deals with big numbers anyway. Okay, so now we've got an array that is padded to 8 bytes, little endian encoded. Okay, so let's run it. 44. It's like bingo. Okay, done. Um, yeah, so you can imagine how you would like encode and decode into these like buffers that look exactly like this, any kind of data that you're sending back and forth. And Borscht helps with that, but at least now like you can understand what's happening under the hood. There is a little bit more complexity around like how keys works, how signing works, how multi-sign works, and all that stuff, but not much. Once you kind of understand like this stuff and the structure of Solana accounts and programs, it all becomes pretty straightforward. And you're just collecting together these little Lego blocks that are accounts with programs and data attached. So I hope that was in some way helpful. Yeah, from here, I guess you would want to sort of fill out these switches, and maybe you would even deserialize these switches into an enum, and then this is what all this stuff, all the example programs do, is they're just deserializing the data into like a series of instructions and then processing those instructions. So you can already hear the words that are present in the different Rust files that are in those typical examples, like instruction.rs and processor.rs and state.rs. All of those things are for storing, like state would store the model data, like the structure, model schema or structure, and instructions would be each different, the deserializer and serializer for the instruction enum, and then the processor is the functions that actually get called out of those those instruction enum arms. It's very similar, like if you've ever written an emulator, it's a similar sort of structure. Yeah, as like interpreting bytecode from a ROM or something like that. Of course, you don't have the same like memory stuff, but it's very similar anyway. The way that the processor works. I hope that helped, and yeah, let me know if you want me to make anything else.